repair. So today we have this, they say it's a digital mixer core unit, CapitolIP, maybe that's the brand, CapitolIP digital mixer core unit. So it's just to do with sound. So it says it's a core unit, so maybe there are other units, maybe another preamp something, or this is the preamp itself, or there's another preamp, and then there's amplifiers and stuff connected through this. I'm not sure how it works, but the fault with it, we identified on the power supply. This is the power supply of it, of which I had already isolated a few things that were faulty. There is a bridge rectifier that I've removed, short, and then on these MOSFETs, these two MOSFETs, they are bad also. So, and I see here there is some ICs. Well, from the look of it, and without delving much, I can see that this module obviously is paired up with these modules. With these MOSFETs, these probably are MOSFETs or IGBTs, these two. So you can see there's symmetry here. I can see some bit of symmetry. There's one IC, and then it's like an identical circuit. So probably this IC drives one MOSFET, the other one drives the other MOSFET. Probably in a high side, low side a driver configuration, driving this transformer. Well, from the look of it, and it's got a single output. You can see there, it's just a single output, which goes up to there. They say it's supposed to be a, it's supposed to be a 48 volts. Can see there's written 48 volts. So it's a single output, 48 volts. And then from the 48 volts, obviously you will need something to produce the smaller voltages. So I've identified these, there's several modules here. See this one, it says V in, and then V out. It's a dual supply, V out negative, V out positive, and the common. So they say it takes 18 to 75, probably the 48 volts coming in to produce plus minus 15 volts at 1 amps. Then we've got another one there which produces also, it's a dual supply output, positive and negative output. So this one produces a plus minus 5 volts DC. So, and I also identified there's an LM. It's probably some kind of voltage regulator. This LM something, I think, I'm not sure, but looks like so. And then here there's another one here. There's another one here. So by the look of it, I've checked for shorts, just random shorts on the caps, and I didn't find any. So probably it's only the power supply that's bad. But I'm not gonna fix this power supply. Instead, I'm gonna use this transformer. See, this transformer, it's rated at it's got several outputs, but the one that I'm concerned about, that I'm interested in, is the plus minus 17.5 volts AC. Remember, a transformer produces AC. So from here, these other voltages I'm gonna ignore. These other windings I'm gonna ignore. The 24 volts one and the 6.8 volts I'm gonna ignore it. So we're just gonna use this one in combination with the bridge rectifier and the capacitor. This capacitor, I actually removed it from here. It's quite a difficult capacitor to get. I removed it from the original power supply. It's rated at let me zoom in. It's 63 volts for 70 micro. So that's the one I'm gonna use. So never mind this this thing. Remember, this is the AC output of it. But if you put this AC output into a bridge, ignoring the center tap, check the two leads 1717. At that, you produce maybe it's around 35 volts AC, at voltage difference of 35 volts AC. So from that 35 volts AC, actually, if you do the calculations, you're gonna arrive at around 50 volts output, which is quite fair compared to the 48 volts. Maybe it's gonna be 49, 50, 51. Because sometimes the windings are not exact. You can say sometimes it could be 17.5, yet it's not 17, maybe it's 18, or it's 18.5, depending. You see these transformers, sometimes they're not exactly on the mark. So that's what you're gonna use. to bypass this power supply. So this is the input. I've already connected the input through a fuse. This transformer fortunately has got a line fuse. So this one goes straight to the input of the power. Then the output of the transformer will go to the bridge rectifier. AC input in the middle, you see the pink wires. Then the outputs, positive and negative, would go, one go to the capacitor, then the other would go straight there to the 48 volt line. So I think with that setup, we will actually win on this one. So what I'm gonna use was some hot glue. It still hasn't dried, still wet. I've just put it now. You can see it's still malleable. What I've done is I've put some hot glue for the bridge rectifier underneath, and then the capacitor lying flat on top. Nothing is touching. Looks pretty neat. Then I'm just gonna put this setup where the power supply was. I've already opened this, and I think this shielding is gonna work. Maybe because this is a transformer, maybe it's gonna produce some noise. So this shield is probably gonna protect maybe the electronics underneath from some bit of interference that might come up out of that. Okay, so this is it. This is how we have hooked it up. I've already plugged it in, so now I'm just gonna press the power button there. Okay. Right, so now it's on. I see the green light, I see some flashing lights. I heard a relay somewhere clicking. See those flashes there. Something is happening there. There's a light there. Maybe you can just quickly try and see what the lights are for. Maybe this one looks like a good light, like it's working. This one, the way it is, looks like it's working, I think. And this one also, maybe these lights indicate maybe they are for faults, so that you're able to see a fault. So because this one is flashing like this, maybe it's working. This one maybe it's working. This one maybe it's working. There are no markings for me to see from, maybe to see what the lights might indicate. So what we can just quickly check is whether our voltage is still nice there. It should be. Oh, it sagged a bit. It sagged. It was 50 before, but when it comes on, maybe it sags. It sagged up to 48. It sagged. But I don't know why. Maybe it needs a bigger cap. Maybe the cap that I put, but that's the original cap. Maybe because of the transformer. But it looks like it's fine. Maybe you can just test it whether it works normally. It works normally, gonna leave it like that. If maybe it doesn't, I'm thinking maybe I could just put a bigger cap. This is a 470 micro. Maybe I can find a 1000 micro one. Maybe the voltage won't sag so much. So for interest sake, because I see there is some voltage regulators here, I just want to know what they're supposed to produce. Oh, this one is the 3.3 regulator. Oh, you can see there 3.3. Where is it? Oh, where's my prop? Yeah, there, 3.3. So which means maybe this cap is a 3.3. Yes, that's 3.3. Then there was another LM. This one. Oh, this one's the 5 volts. So the 5 volts is there and it's stable. There on that other voltage regulator. And then I saw another one here. Okay. I felt something. Okay. Oh, that's also a 5 volts regulator. You can see there the 5 volts stable. Well, there are no other things that I see obvious, that are obvious. Oh, there's another IC there. You see this IC? Let's see. This should be ground. Oh, that's not ground. That's 40 volts. And then that's 41. And this is 39. But it's working. I can't see the marking, so I don't know what it is. Maybe I can just try. Oh, it's another LM. I think this thing is fine. I think. So we're just gonna leave it at that. Let me just switch it off. Just watch the lights. See, the green light goes off. And then if I power it on, it comes on again. Okay guys, this is a CapitolIP mixer. It's actually 2 units. It's got the mixer where you do your DJing thing that you can do here on this one, and then this one is the core unit that does the processing and everything. So the fault with it was this power supply. That's the original power supply. Together with this, that's the PWM controller module. So we, instead of using this, we put a transformer, and it fits nicely because the cover is going to fit there at the top. So as you can see, all the lights there. I think the way they are flashing, I think that it's normal. Some things flash like this, and this one looks normal. I think everything looks normal. I tested the voltages. You see there's an LM IC here. Actually, let me start from the beginning. This thing checks in here 42 volts, 48 volts, sorry. It checks in 48 volts. From the 48 volts, you've got some power modules here. This power module checks in 18 to 75 volts, giving out plus minus 15 volts. And then we've got another module there, which produces plus minus 5 volts from the 48 volts. But actually, these modules, they are rated from 36 to 72. 36 to 72. So, but this one nominally, the normal voltage is supposed to be 48 volts. So, I tested the voltages I could get here. I remember it was a 3.3. And then maybe here it was a 5 volts, and then another 5 volts somewhere. And of course, you have 15 volts. They should be somewhere here on the output. I tested them before. Also got another regulator. So these are regulators. Remember, the 48 volts, all these ICs won't use their 48 volts. They need lower voltages. So you've got one regulator that I can see. 1, 2, got another one there, 3. Then you've got another one there, 4. I can identify 4 just by looking. Maybe there is another somewhere that I can see, maybe underneath. Oh, there's another one there. Then there's another one there. You can see there. Let me try and zoom in. Can see where I am pointing with my finger. Oh, here, there. 1, 2. So it's 1, 2, got 3, 4, 5, 6. Okay, so this is what we did. Sometimes you need to think outside the box. But of course, if you are able to source the original ICs, this one is it's an IR 2183 high side low side driver. So it's a high side low side driver, and then the other one it's a TL. It's an adjustable Zina reference. I can't remember the exact number, but it's the TL range. Remember the TL 431, the TL 317, TL something. So it's one of the TL packages. It's a 3-pin. Never mind the 8-pin package DIP. It's actually 3 pins. So this is it. So as you can see, looks like it's responding as I'm pressing. I don't know how to operate it. So someone who knows is going to test it to see if there's anything else wrong. They're going to tell us. But I can see it's responding, even though I don't know how it's supposed to work. Okay. 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 Right. So thanks guys for watching. Maybe I'm going to send the other video where I actually did the repair of it. How I was able to diagnose the power supply, but just quite a straightforward fix without doing this one in particular.